As I told you in the last video, the iterable interface is at the top of our hierarchy. Now, more accurately, this interface is not part of the collections framework. In fact, it's part of the java.lang package. So it's one of the fundamental interfaces in Java and represents an object that we can iterate or loop over. Now, before we look at the specifics of this interface, let's talk about the problem it tries to solve. So here in the main method, I'm going to create a generic list, new generic list of strings. Let's add a couple of objects here. So add A and B. Now we want to iterate over this list and print each item. So we write a for each loop for item in list. Look, we have a compilation error here. For each not applicable to type generic list. Now, one way to solve this problem is to go back to the generic list class and make this private field public. Then we'll be able to access the items array from outside of this class. So here in the main method, we can type list.items. Now we can iterate over this array and print each item. Now the problem with this approach is that we have exposed the internal implementation of this class to the outside. So if we decide to change this implementation in the future and replace this array with a different data structure, all the code that is dependent on this field will have to be changed. As a metaphor, think of the remote control of your TV. This remote control has a few simple buttons for you to work with, but on the inside, it has a complex logic board. That's the implementation detail. Now, if tomorrow the manufacturing company decides to change this internal implementation, you are not going to get affected. If they replace a transistor with an advanced model, you can still use the same buttons you're familiar with. So changing the internal implementation of a remote control should not impact its public interface. In object-oriented programming, we should design our classes in the same way. Again, I talked about this concept a lot in the second part of this series. So back to our generic list, we should not expose the items field to the outside because this is the implementation detail. Let me show you the problem with this code. With this implementation, we can go back to our main method and write code like this. List.items of 0. We set this to a string like A, and then we can print list.items.length. Now, what is the problem here? Well, there is no problem right now, but if tomorrow we decide to replace this array with an ArrayList object, our code is going to break. Let me show you. So we type ArrayList of T. This is a class declared in the collections framework, and it's an implementation of a dynamic array. We're going to look at it soon. So let's create an ArrayList object here. New ArrayList. Now, back to the main method. See what happened? Our code broke because the ArrayList class does not support the square bracket syntax for accessing an object by its index. Also, it doesn't have a field called length. So a simple change in the implementation detail of our generic list resulted in two breaking changes in our main method. Now, this is a very simple program, but in a real application, we could have hundreds of references to our generic list. So if we change the implementation detail, then we would have to go back and fix all those hundreds of places that are broken. So here's the question. How can we iterate over a list without knowing anything about its internal implementation? That is where the iterable interface comes to the rescue. In the next video, I'm going to show you how to solve this problem using the iterable interface.